The second part is semi-interquartile range or quartile deviation. If the data contains extreme values or outliers, then the range is an incorrect measure of variation. In such cases, we use a measure of dispersion based on quartiles to get rid of the effect of the extreme values. This measure is called quartile deviation or semi-interquartile range, and it is defined as follows. So what does it mean that range uses only two extreme value, that is the largest value and the smallest value? So it cannot give us the real picture of the dispersion. So to overcome this limitation of range, we take the range of middle 50% data together. This 50% data lie between the two quartiles, quartile 1 and quartile 3. So quartile deviation gives the half of the range of middle value, that is 50% of observation. It is called semi-interquartile range. And what is a formula for it? Let's see here. Quartile deviation Q3 minus Q1 upon 2. It can also be named as interquartile range upon 2. How you can find interquartile range? Q3 quartile 3 minus quartile 1. With the help of this formula, you can find quartile deviation. Now let's see some examples. Find the quartile deviation for the following data. Now here the data is given to you. In chapter 1, we have studied how we are going to find quartile 1, quartile 2, quartile 3. In the same way, we are going to find here quartile 1 and quartile 3. So first step is to arrange the data in ascending order. So this is the way we will arrange the entire set of data in ascending order. Now here n, number of elements or number of observation, if you see, it is 11. So just put the formula of quartile 1 first. Value of n plus 1 upon 4th observation. Value of here n is 11, so 11 plus 1 upon 4th observation. So value of 12 upon 4th observation. When you divide this, 4 1s are 4 3s are, so you get value of 3rd observation. Now check the data. Which is the 3rd observation? So 1, 2, 3. This 5 is a 3rd observation. So our quartile 1 will be 5. In the same way, you have to solve quartile 3. The value of 3 and open the bracket 1 n plus 1 upon 4th observation. Value of 3, 11 plus 1 upon 4th observation. Now when you solve this, you get 3 into 3. How you got 3 into 3? Your 3 is already given to you. 12 upon 4 will give you 3. So multiply by 3. So 3 3s are 9th observation. Now when you check the 9th observation here from the data, you get it as 16. 16 is a 9th observation. So 16 is your quartile 3. Now just put the formula of quartile deviation. Q3 minus Q1 upon 2. That is 16 minus 5 upon 2 will give you 5.5. Let's see one more example. Now here calculate quartile deviation for the following data. So X is given to you and F frequency is given to you. So just put in the table like this and first add all the value of F. When you add it, you get 30 here. So write n is equal to 30, but always make less than cumulative frequency first. So here is 6 frequency, so write here 6. Then 6 plus 5, 11. 3 plus 11, you will get 14. Then 14 plus 2, you will get 16. 16 plus 4, 20. 20 plus 7, 27. And 27 plus 3, 30. This 30 and this 30 should be equal. Now with the help of this table, we are going to find quartile 1 and quartile 3. So let's move further. Now n is 30. So for quartile 1, value of n plus 1 upon 4th observation. So your n is 30, so 30 plus 1 upon 4th observation, you will get value of 7.75 observation. Now here, remember this 7.75. So go back and imagine where 7.75 will lie, between 6 and 11. So always take the maximum one, 11, and keep it as quartile 1, first part. Then next is quartile 3. So value of 3 n plus 1 upon 4th observation. So here 3 and open the bracket here, 30 plus 1 upon 4th observation. When you solve it, you get 3 multiplied by 7.75. When you multiply both this value, you get 23.25. So turn the page here, you get 23.25 between 20 and 27. It will lie between these two values. So always take the maximum one and mark here as quartile 3. So now your quartile 1 will be, select the answer as X, 25, and your quartile 3 will be 29. And then just put the formula of quartile deviation, Q3 minus Q1 upon 2, 29 minus 25 upon 2, 4 upon 2 is equal to 2. So 2 is the quartile deviation here.